Over the last few videos, we wrote this little terminal app in Elixir, and we sort of manually tested it, a little bit. But I know there's some bugs in this app. For example, watch what happens if I key in a command that isn't in the list of commands we see down here. And bam, our app died. This is one of those in-your-face, you can't miss it bugs, but there's likely some other, more subtle bugs as well. So how should we find and fix these bugs? Well, we could keep manually testing it and fix the bugs as we find them, but this isn't ideal for several reasons. The biggest reason in my mind to avoid manual testing like we've been doing is because the effort we spend manually testing is somewhat wasteful. What do I mean by wasteful? Well, when you're manually testing, there's a time investment on your part that provides some benefit to you, but it only provides that benefit once. In other words, in a week from now, when we make some changes to the election module, you're going to have to manually retest things that we previously tested. It would be better if our testing time investment provided a recurring benefit, and the way you can achieve this is by writing tests in your code that can be executed over and over again. So how do you write tests in Elixir? Well, there's a few tools we could use to do this, but the most popular testing tool is the one that's automatically included with Elixir and Mix, which is XUnit. Now, earlier in the course, I showed you how you could write tests inside your documentation, but I never actually showed you how to run the tests, because at the time, we were writing Elixir in Elixir script files, which were outside of a Mix project, and XUnit isn't really meant to work outside of a Mix project. However, now that we've started to use Mix projects, testing is a lot easier. So let's do this. I'm going to pull up our election module, and first of all, I'm going to remove most of the default values in the election struct. Then I'm going to write some docs for the update function, and I'll write one doc test, which is the type of test I showed you earlier in the course. I'm going to pause recording for a moment and just write the docs for this function offline, because there's a lot of typing and it's sort of boring. Okay, here's the docs I added for the update function, and right here in the example section is a code example, but it's also a unit test. As long as you follow a couple of simple formatting rules, your code examples can actually be executed as tests. So what are the formatting rules I just referenced? Well, in your docs, you need to indent 4 spaces, then you need to write IEX as if you were demonstrating how to call this function in the REPL, then right here, you'll make a function call. Now on the next line, right here, is the value you expect to be returned from this expression here. Essentially, I'm asserting that this function call should result in this value. So how do you run tests? I showed you this a while back when I was introducing you to Mix projects. So to run tests, you use our general purpose build tool, Mix. If you run Mix help, you see all the different Mix tasks that are available to you, and down here is the test task. So let's try running Mix test in our Mix project directory. Okay, did anything happen here? I mean, we didn't see any failures, which is good, but check this out. The response we got was, there are no tests to run. Okay, so our doc test didn't run for some reason. Well, the reason it didn't run is because we've got a little bit of setup to take care of still. When you run the Mix test task, XUnit checks for any files in the test folder that end in _test.exs. But if we peek at the contents of the test folder, there aren't any files that match this file name pattern. We only see the test helper script. Okay, so to fix this, let's create a test file. There's a convention for naming your test files. You should create a test file in the test directory that has the same relative folder hierarchy as the file you want to test, and the name of the test file should match the name of the source file you're testing, except it should have an _test appended on the end, and of course, all test files are script files. So I'll create a new file in the test directory folder named election_test.exs. Our test file should contain a module that includes our tests, and I'll name the module election test, and notice the module name matches the file name except the module name is in camel case. The next thing I'll do is use the xunit.case module, which essentially injects a bunch of code or functionality into this module from the xunit case modules using macro. So do you think our doc test will work now? Well, let's see. Okay, well, the output of this test run is different, but it's still not working. We don't see any indication that some tests will run, and the reason it's not working is because we have to explicitly tell xunit to run doc tests, which is done by using the doc test macro and passing in the module we want to run doc tests on, which in our case is the election module. Okay, let's try our test again, and cool. We see one doc test was executed, and there were 0 failures. So should we do all our testing as doc tests? Well, generally speaking, that's a pretty good idea, but practically speaking, it doesn't always make sense. I'll explain what I mean in a moment here, but for now I'm going to pause this recording just for a moment, and I'll write a few more test cases for the update function, and I'll show you what I came up with. Okay, here's a few other test cases written as doc tests. So how do these examples look to you? Well, to be honest with you, I don't really like what we ended up with here. These examples are super noisy and hard to read and just ugly. I think using doc tests is great when the function calls are relatively simple, like this one. However, most of these tests are ugly, at least as doc tests. So let's do this. I'll leave the top one in the docs, but I'm going to get rid of the rest of these tests, and we'll start writing these test cases in the test file we created a moment ago. So let's go write some tests. When we use xunit case, as shown on this line, a whole lot of test-related functionality is made available for you to use. So for example, we get access to the test macro, which we'll look at right now. So I'll call the test macro, passing in a description of the test we're writing, which in our case will be testing the updating of an election name from a command. So the next question is, how do you implement the test? Well, when you write tests, you're essentially doing 3 things. First, you're arranging, which entails setting up for the test. In other words, creating values to use in your test. Next, you're acting, which means you're invoking the function to test using the test values. And finally, you're asserting, which means you're verifying the value returned from the function is what you expected. So let's start by arranging our test. First, I'll arrange the input values, so I'll create a command, which will be the string name followed by the name we'd like to use. Next, I'll create an election struct. Now that we've arranged some values to test with, let's actually act on these values. So I'll call the election module's update function, passing in the election struct and the command, and I'll rebind what's returned from this function call to the election variable. The final step to testing is to make one or more assertions. To do this, I'll call the assert macro, which is available to us from the using macro on this line. The assertion I'll make is that the updated election struct should equal an election struct where the name matches the name we passed into our command. All right, let's run our test again to see what we get. Okay, one doc test was performed and one regular test was performed, and we had 0 failures. Let's see what it looks like when a test fails. To do this, I'll tweak the assertion by changing the expected name, and then I'll run our tests again. This time we had a test fail, and as you can see right here, xunit is providing details on why the test failed. The left side of our assertion had the election struct where the name was this, and the right side had an election struct where the name was this, and since these are different, the assertion failed. Now I'll go ahead and fix our test. Sometimes you'll be running mini-tests that have similar arrangements. In other words, mini-tests will require the same test data, at least in part. So for example, in the tests we're starting to work on, there's a pretty good chance every test will need an election struct. You can save yourself a bit of repetition by using another testing macro, the setup macro. The setup macro will run before every test, and whatever we return from the setup macro will get passed into our tests where we can use it. So for example, let's say we'd rather not construct this election struct in every single test. So instead of doing this, we could create an election struct in our setup macro and return it as, say, part of a map with a key named election. This returned map represents the context information each test can use if needed. The way our test can use this context information is by accepting a second parameter, I'll name CTX, then I can use ctx.election as my test data, and I can get rid of this line right here. Let's try running our test again, and they're still working. Cool. There's one more commonly used setup macro, which is the setupAll macro. This macro is similar to the setup macro, but it runs just once for all the tests. So to summarize, the setup macro runs before calling each test, whereas the setupAll macro runs just once for all tests. Okay, I've got a challenge for you. I've added a few test heads, as you can see here. These represent tests we plan on writing but haven't implemented yet. I'd like you to implement these tests to get some practice writing tests in XUnit. You'll find instructions on how to get started with this exercise after this video. In the next video, I'll share some thoughts on what we've done over the last several videos, and I'll pose a question that will lead us into what I consider the most important feature in Elixir.